Thank you for that, George. Uh, so the one thing about being last, or one of the last, is that my presentation has been given about 5 or 6 times already, so I can move along a little faster. Uh, the question, as I saw it, was, do smart weapons cause us to go to war more frequently? And as a former commander, my first answer to that would have been absolutely not. We only go to war when we need to go to war, and the weapons really don't make a difference. But my thinking actually is different than that. I actually do believe, my short answer to the question is, I do believe that the presence of smart weapons would allow us, or would maybe urge us to go to war more frequently, and I'll try to talk about that. A point was made earlier, I'd like to address that, about Putin and the presence of smart weapons on the battlefield, whether or not it had any impact on Ukraine. I don't know whether you want to call these smart weapons, but if you remember, in about a year or two in the lead up to the Ukraine invasion, Putin was all over the map with introducing avant-garde and Kalibir and several other super weapons. And I wonder whether or not he was believing his own press clippings and maybe thought that he was going to make him invincible. And it could potentially. I also want to point, someone mentioned Oppenheimer. Apparently, I go back to an interview he gave in 1964 in which someone asked him about the use of the atomic bomb, and his short answer was the use of the atomic bomb was implicit in the project, which is a very, very strong statement. And so that's another one of the reasons that I think many times these new weapons, when they appear, they invite their own use. And so that's one of the things. So next chart, do we have a clicker? Yeah. So I'm going to take an attempt at what are they, and then talk about how they might lower the threshold. I'd probably take a peculiar approach to this, and you'll see what I'm talking about in a moment. And unfortunately, you can't really read this, but smart technologies, computing and telecommunications technologies combined with artificial intelligence and machine learning and big data analysis. And when you can put all that, embed that in electronic devices and connected devices together with network protocols and into an internet of things, you begin to approach what I think of as smart technologies. And I have a little box down at the bottom. I probably should have put it on a different chart, but it talks about these technologies, these weapons, but if you want to call them, are elements of what is known as a complex adaptive system. And I think that's a key term, complex adaptive system. And that the behavior of these networks, these internets of things, become more probabilistic and less deterministic in the way they behave to input. Smart weapons, computer-controlled weapons, missiles, bombs, smart bombs, centrifuged weapons. I won't go reading through all of these. Laser, infrared, radar, satellite guidance, advances in robotics and digital technologies. They're likely faster and more resilient than your typical weapons. And fourth bullet down there, I talk about command and control systems and digital support systems. And I will probably spend the better part of this discussion talking about those, because I think they're probably, at least in my mind, more important, or at least as important as weapons. Just a couple of pictures here. The military Internet of Things. A lot of people are surprised to know that bombs hanging on the wings of airplanes have their own URLs. And so they're all part of the military Internet of Things, where you have sensors and shooters and weapons and everything all connected. And then the bottom picture shows the modern battlefield, because everything is connected and it's all done via communications technologies. The electromagnetic environment on the battlefield is going to be very dense, and that could present a real problem for us. And so my bottom line of that is that this is going to present commanders with increasingly ambiguous tactical situations. And I think we're probably also finding that now in Ukraine. So what might lower the threshold? And I've listed a number of things. The first is the reduced risk to the attacker. If I'm at less risk, then I might be more inclined to take an action than I would be otherwise. Lower cost is probably one of the most important ones. Obviously, higher speed. If we can get the thing done faster, then we might be more willing. And then probably importantly, ill-informed decision. That's the one I pay a lot of attention to. I don't talk about reduced attribution, but anything that these smart technologies can do to help us gain stealth might also lead us to do something. Reducing the risk to the attacker is not a drone thing. I mean, that's what most people think of. But we've been trying to separate ourselves from the battlefield for centuries, starting with longbows and artillery. And we've got JDAM missiles and joint air-to-surface standoff missiles and tomahawks. And my colleague behind me could probably list another 100 or so precision-guided munitions. So talking about the importance of distance, some of you may have read Dave Grossman's book on killing. He talked in there about how soldiers often in battlefield don't even fire their weapons. Soldiers at close range exhibit a real resistance to killing. Like Martin was talking about yesterday, I actually had an email exchange with an old World War II veteran who described to me what it was like to stab a German soldier and watch him die. And he remembered that 70 years later. So at long range, it's a lot easier, and technology allows us to get farther away. And the implication there, and the bottom line of this is that Grossman contends that the extreme distancing can cause us to be willing to kill a lot more freely than we might otherwise. Lower cost, obviously precision-guided munitions, they're not lower cost. As a matter of fact, they're high cost. But we have to use so many fewer of them that on balance, it's probably lower cost. And higher accuracy, lower risk for the target. And you can find these anywhere, these charts about precision-guided munitions. What's really interesting is that the number, and this is dollars, but the number of precision-guided munitions being purchased has been very high since fiscal year 16. You can see over there on the right-hand side, the number of long-range missiles has been going up fairly rapidly. That could be as a result of Ukraine. But the question is this that we're just increasing our stocks, or are we using them more frequently? And if we're using them more frequently, it might imply that the fact that we have them has invited their use. Lower cost, I won't go through these in detail, but ISIS modified quadcopters to use in battle. Ukrainian forces have modified drones, we know that. Chinese drones are pretty much found everywhere. Computer systems, large language models, AI systems, software, comparatively inexpensive, commercially available satellite imagery and communications. Someone mentioned Elon Musk yesterday, but that happens a lot. I want to focus on command and control. I actually had some experience in building command and control systems in one of my previous jobs. Too often we think of the weapons themselves, command and control, this going back to my question about complex adaptive systems, these are a perfect example of complex adaptive systems. They're not deterministic. The command and control system actually includes people and procedures, not just facilities and equipment. And I was interested in Nita's discussion yesterday about command and control systems. I couldn't see many of the components, but suffice it to say that these things, the global command and control system, for instance, have literally hundreds of components, many of which are built by dozens of contractors, many of whom are using different AI systems that all have to be stitched together in a big command and control system. And so the outcome of that is complete unpredictability. We have been used to in the military talking about kill chains. You all have heard of, find, fix, track, target, kill. Now we're talking about kill webs, in which we've stitched together a whole bunch of different kill chains. And so one sensor operating somewhere in the world might see something and then hand it off to a different. So you see down in the bottom left-hand corner, if you could read it, it says this system then offers the commander's prioritized option. Rapid decision making. So any of you have ever read Hal Moore's book, We Were Soldiers Once and Young? It's an excellent book. He describes battle in Vietnam in 1965, in which he was able, in an intense battle, to actually stand back for a moment and try to figure out what was going on. He called it his moments of reflection. In current situation, we have a lot of information, too little time. Leaders are deprived of the ability to think. And if you may have read the book or the piece by Simone Weil, the Iliad or the Poem of Force, in which she says, between the impulse and the act, the tiny interval that is reflection. And I contend that in the speed of battle, the commanders are not going to have time for reflection. Probably not a great example, but hypersonic missiles, because they're so fast, they give commanders little time to actually do good decision making, and they might make an ill-informed decision. And then, because this is all connected in a network, it creates an efficient weapon system. A mistake by one actually could make its way through the entire system. So I think, okay, so decision support systems might lower the barrier for war. One of the DARPA program managers who's involved in these systems talks about them having more apparent competency. And I say decision support systems, these command and control systems. The soldiers will be instructed to treat these digital assistants with enough mistrust so that they safeguard their own judgment. But the point he makes is that we trust them so much that the ability to refuse the information is very hard for them. So one of the dangers of automated decision support systems is over-reliance. We build up trust with these systems, and if one fails in a way that is not obvious, the users actually fail to notice it. So if an artillery piece misfires, you know it's misfired. If your decision support system fails, you might not know it. And then you create complacency by keeping the expert. You want the expert actively involved, but unfortunately, the automation induces complacency. And the last point there is Whereas in the past, we could figure out our systems. These are so complex that we have no idea how they work. So it's very unlikely that we would know how to fix it or that even anything was wrong. So I'll just very quickly, automation bias. We actually have a tendency to give technology more credence than we give our own knowledge in many cases. And very often we just select the path that requires the least cognitive effort. And complacency, because we use these things so often, and they are so often right, we don't even suspect that they're going to have errors. And we think that the technology is better than humans. That's kind of what we were talking about yesterday. And then, unfortunately, it just convinces the humans to turn the tasks over to the machines. I'm just going to show you, to give you the data. There was an actual study. It was a pharmaceutical and therapeutic study. And it basically says that when they perceive automation as reliable 70% of the time, people are less likely to question its accuracy. We depend on it. And then what was really scary, it was that clinicians overrode their own correct decisions in favor of erroneous advice from the technology between 6 and 11%. So having an over-reliance on the technology could be fatal. These have all been talked about. So the bias in programming for AI systems, data issues, data bias, inadequate real-life combat data for training, the fact that they're subject to spoofing and hacking, which is possibly undetectable, all give AI systems a great deal of unpredictability. And many times what they come up with diverges from what human logic would say. Not to say that human logic is always right, and the fact that they're not explainable, although that's being worked on fairly. Escalation, it could be accidental, it could be inadvertent, or it could be deliberate. I focus on my next chart on the ambiguity and the potential for inadvertent escalation. So decisions in the face of ambiguity. So faced with ambiguous information, people most often opt for the lowest regret, most conservative response. I think probably everyone in this room has been faced with a situation where they didn't have enough data, so they took the lowest regret. Faced with an ambiguous military situations, commanders might reasonably be expected to opt to take action when action may not actually be called for, but not to take action would be. And frankly, I experienced this several times in commands that I've had where I didn't know the situation, so I just opted to do what I thought was the right. So just summarizing, in a blinding flash of the obvious, smart technologies will play a major role in future conflicts. And while current technology may allow a reasonable level of discrimination, and that's subject to some debate, I, like many others, don't believe that it's sufficient for necessity and proportionality. My main point, most militaries are highly professional and highly trained, even our adversaries, and commanders take their responsibilities very seriously, and they will resist turning over important decisions to machines. But at some point, they will just be overwhelmed and not be able to take all the decisions themselves. So all things considered, I think smart technologies will likely lower the threshold for violence. And I'd like to end with a potential solution, and that is in the acquisition process to require contractors who actually build these devices to include in them what I've referred to as speed brakes or kill switches, something that can be used to actually disable the system. And so with that, I'll end.